Hello and welcome. We are the Science Center of Iowa Tornado Simulator, and this is our Fall 2014 Design Review. My name is Nicholas David. I am the team lead. I'm a senior in aerospace engineering.
My name is Ben Guo. I'm a junior in aerospace engineering.
My name is Joshua Curtis Beard, and I am a junior in mechanical engineering.
And our advisor is Andrew Jordan. So what we're going to be going over is what we learned from last semester, the current state of the design, the project plan, and our budget. So our goal is to build an interactive tornado simulator for the Science Center of Iowa. This semester, we are going to deliver a final concept drawing to Science Center for their large-scale tornado simulator. And the next semester, we're going to have SolidWorks drawings, including a bill of materials and cost estimates for each item.
Okay, so right now, this is our original design versus our prototype design, obviously. A few differences between our original and prototype. Our original design, the one we had started designing in SolidWorks, did not look attractive at all. Sending this to the Iowa Science Center would not be acceptable. So it's obviously been refurbished and it looks a lot better. And so now we'll just kind of discuss what we've learned from this process. One of the things that we've learned right now, or that we're constantly learning, is that we need a really good design for structures, the efficiency of manufacturing, and how these things are going to work. We also decided to have a water vapor. It's better for visualization for kids and for really anybody that wants to kind of go with there to kind of see what the tornado simulator is going to be like. Another thing that we're constantly trying to do right now, or that we plan to do because of these things, is to try to get an analysis of the airflow. So we're going to be writing a MATLAB code for our settings and how high our air velocity is, and that way we can get more of an analysis on the things that we're going to be building before we start building these things, which is super pivotal for the design aspect of our concept. So how do these things help our current design? Well, because our prototype, we're still working on it right now, still trying to order the parts. Because of these things, we can see how our final design wants to be. We see that we've seen our mistakes, we've seen where we want to go from here. Now we just have to implicate these things. A lot of these things imply better structures. Like I said, our original design had really emphasized, had started with the 4 columns on each side, which wasn't very attractive and it isn't good for like the public. So we're working right now on trying to find a better way to show people a tornado simulator from the structures in general. Otherwise, most of our other designs, such as our cans and our vanes, they're going to be pretty much the same, considering those aren't much of the structures, and most people don't look at these things. Though we will constantly, and we will be constantly trying to upgrade these things and work on these things as well, because we don't want anything inefficient. That's just not engineering. Okay.
Sorry. So current state of design, as Josh just says, we learned a lot from the design and prototype we built last semester. So last semester we will focus on 2 themes. First is the concept drawing, and the second is the flow analysis using MATLAB. So right now we already comes out 4 different concept drawings. For 4 of them, the minor design will be in the cans. The specification, the data of the can and design will come out from the MATLAB, and the major change will be in the structural. Since we have a hard time to build a really good structure and build it efficiently, so we did a lot of change and redesign for the structure for 4 of the concept. And after that, the flow analysis, we're using the formulas from the previous the tornado simulator design from the Professor Saka. And we'll use that to define the final define the final data for the can design. So that's the first design.
Okay, as discussed before, we are doing concept drawings, so none of these are permanent. We're trying to figure out best ways to implicate our final design. Right now, this is the first concept drawing. A lot of why this concept in particular, as discussed before, that the structure of it was not appealing to most or to really anybody. So this eliminates the need for four beams and kind of squaring in the can. This gives it more of all around so people can kind of see it from multiple angles. Now, the problems with this one is that it's not structurally sound. Although this is a great way to open the area to most customers or most kids or anybody, it doesn't give us a structurally sound thing. So it could break down at any moment considering there's only two beams at a 90-degree angle. This also, well, the thing at the bottom, that would help. That would help kind of balance it out, but even then it still wouldn't be very well structurally designed. But that's definitely one idea to try to figure out the mistakes from we did last year to how we're improving it this semester. And that's just one of the concept drawings.
So that's the second concept drawing. It's quite similar to the previous one. And this one, the center of the can will locate it inside the triangle structure for the frame. And it will make sure it's stable. And also, this particular design is trying to fit in a corner. So people can walk in from the right side and exit from another side. So also open the space. People can mostly see and walk through it to interact with that. And right now, we're thinking about this design is really easy to build. It's similar to the previous design last year. And third design is like that. So basically can design does not change, but the major change is the structural. So in the bottom will be a circular shape just directly from the ground to the up. And there will be a door open on the side so people can walk into a door and close the door. It will ensure the entire system is closed and make sure the flow is stationary. The bad side of this design just be the heart of manufacturing and maybe expensive.
So this is our most basic design. It has the 4 pillars supported by 2 cross beams. And so the good thing about this is it's structurally sound and you're able to get mass quantities of people through because you have an easy in, easy out. Problem is it does take a lot of space up because it does have those 4 pillars, so it can't necessarily be up against a wall or It has a raised floor so you can introduce the smoke system.
So here is our project plan for this project. So during this fall semester, we'll focus on the concept design and send that to the Science Center and finalize the MATLAB coding in order to define the design of the can. And for the spring semester, we will have a detailed design to including bolts and nuts location for every single part so that we can send this to Science Center, because the project is basically they build the project and we come up with the design. So our plan is by the spring design review, we will have a started for design parts in SolidWorks, so we can finish that by the end of next semester. So that's the detailed plan. Right now we already finished the concept design part. Move on, we will send the full concept design to Science Center of Iowa with pro and con for each particular concept design. With the same time, we're also working on the MATLAB coding in order to figure out those data. After that, we will finalize our concept design and working on that. And for next spring semester, as I said before, we're working on the detailed design.
Along with that, we're gonna do some CFD analysis to make sure the airflow is going correctly and making sure any structural flaws will be pointed out. So we are asking for $750 for our budget. This is to finish up last semester's project, also buy the ultrasonic water fogger for last semester's project, and then also travel to and from Science Center and the proof of design for this semester. So what we went over is what we learned, the current state of design, our project plan, and the budget. Are there any questions?